Okay, let's look at question number 29. Question number 29. All right. Okay, I think the idea here is that we are trying to establish something like this. A squared, A minus B. We are trying to establish A minus B multiplied by A plus B. Then in this case, that will be A squared minus B squared. Then can you see that? Then your A squared minus B squared can be combined with A squared plus B squared and then continue. All right. That will tell you that what is actually 5 in terms of A squared minus B squared. 5 isn't that, can you see that, class? I can replace my 5 as 3 squared minus 2 squared. Because 9 minus 4 is actually 5, right? Therefore, your 5 becomes 3 squared minus 2 squared, and then combine with 3 squared plus 2 squared, and then continue 3 to the power 4, 2 to the power 4, right? And then 3 to the power 8, and then plus 2 to the power 8. And then it go all the way to 3 to the power 2 to the power n, plus 2 to the power 2 to the power n, and then this is going to be greater than 9 to the power 256. All right. Therefore, I think can you see that now you can combine them? Therefore, in this case, can you see that when you combine them, you get 3 to the power 4 minus 2 to the power 4. Then this is 3 to the power 4 minus 2 to the power 4, and then dot. Can I say that this is 3 to the power 2n minus plus 2 to the power 2 to the power n, 2 to the power 2n, and then greater than 9 to the power 256 or 256. All right. Okay. Therefore, can you see that now these two combine again? These two combine again. These two and then continue, right? Did you realize that what you get here is actually 3 to the power 2 to the power n minus 2 to the power 2 to the power n, and then multiplied by 3 to the power 2 to the power n plus 2 to the power 2 to the power n, and then this is greater than 9 to the power 256. Can you see that? Then what is this? What is this? Therefore, I think our indices must be very strong. Therefore, you combine them. Therefore, I'm going to do it slowly for you for this one. 3 to the power 2 to the power n, and then square. Right? And then this is actually 2 to the power 2 to the power n, and then you square. And then this is greater than 9 2 to the power 256. Right? And what does the square mean? The square means that you times 2, right? The square means that you times 2. That means this is actually 2 to the power n times 2. Remember? The power times 2. Therefore, I'm going to do it very slowly so that you can see. And then this is times 2, right? And then this is greater than 9 to the power 256. All right? Yeah. Then in this case, can you see that times 2 means what? You can actually put it as 2 squared, and then this is 2 to the power n. And then this is 2 squared, 3 squared 2 to the power n, and then this is 2 squared 2 to the power n, and then greater than 9 256. Therefore, you get 9 2 to the power n minus 4 2 to the power n, and then greater than 9 256. Therefore, why I want you to do it in this way, so that you can see that this is 9, this is 9. All right. Then now you do a checking. You can say that, can you see that 256 is actually 2 to the power 8. 2 to the power 8, right? Therefore, in this case, can you see that when n is equal to 8, right? When n is equal to 8, you get 9 256 minus 4 256. Right? And can you see that this part here? Can you see that when n equal to left-hand side is actually 9 to the power 256 minus 4 to the power 256. And obviously, this is actually less than 9 to the power 256, right? Therefore, 8 is too small. 8 is actually no good. 8 is no good because we want this expression to be greater than 9 to the power 256. Therefore, in this case, I take 9 n equal to 9. Therefore, can you see that 9 to the power 2 to the power 9 is actually equal to what? Is actually equal to 9 to the power 512. Therefore, this is a very big number, right? And obviously, this is greater than what? This is greater than 9 squared. No, this is equal, sorry. This is equal to 9 squared and then raised to the power of 256. So that you can see things better. And this is actually 81 to the power of 256, right? All right. And can you see that 81 is really a very big number, right? But I'm going to reduce it a bit, a lot. That means I'm going to reduce it as 9 plus 16 and then raised to the power of 256. I think you will understand why I make it 16. And I think you know binomial theorem. I only take the last one. And this is going to be greater than 9 to the power of 256 and plus 16 to the power of 256. Okay, if you don't know binomial theorem, right, can I say that A plus B, let's say raised to the power of 256, right? What do you mean? What do you get? You will get A to the power of 256 plus a lot of in-between terms. Then the final term is B to the power of 256. Therefore, can you see that all these terms are actually positive? Therefore, can you see that obviously this expression 9 plus 16 raised to the power of 256 is greater than 9 to the power of 256 plus 16 to the power of 256, right? Then can you see that what I want you to realize is that why I use 16? I use 16 with a reason, because you know why? This is actually what? This is 9 to the power of 256 plus 4 squared. 4 squared, and then this is 256, right? And this is actually 9 to the power of 256, and then this is plus 4 to the power of 512, or 512, right? And in this case, can you see that this is 9 to the power of 256 plus 4, and then this is 2 to the power 4 to the power of 2 to the power of 9. Then in this case, can you see that let me write this thing, Can I let's don't forget our focus. This is 2 to the power 9 to the power 2 to the power 9, and now this is greater than 9 to the power of 256 plus what? Can you see that this is plus 4 to the power of 2 to the power 9? Therefore, if I bring it over, therefore I get 9 to the power of 2 to the power 9 minus 4 2 to the power minus 4 to the power of 2 to the power 9 is greater than 9 to the power of 256. Therefore, in this case, can you see that I got this relationship? Therefore, n equal to 9 is the smallest integer. Because 8 is not enough, it's the smallest integer. Smallest such integer, right? Therefore, in this case, I think we are done. Right? Because they want you to find the smallest positive integer. Therefore, in this case, can you see that n is the smallest integer? Right? Yeah. Okay. Therefore, I think I stop here. Yeah.